All right, now let's take this newfound idea of using inverse trig functions to solve for angles and solve for some angles. Okay, so we've got three cases here. All right, I'm gonna put some lines up here just to make sure we're not encroaching on other territory. So I like to just because it helps me. I like to always mark the angles that I'm solving for, just to make sure it's not there's no confusion on what I'm doing, right? So on this one here, we're solving for this angle right here. So what you do is, first of all, let's label, right? Let's label our sides. So if this is my angle and we label our side, this is going to be my opposite, this is going to be my adjacent, and this is going to be my hypotenuse. Let's just go ahead and label everything. So this is going to be my opposite, this is going to be my adjacent, this is going to be my hypotenuse, and then here's your opposite, here's your adjacent, and here's your hypotenuse. If it's easiest, I always start with the opposite because I always reference the angle first. But if it's easiest for you, do the hypotenuse first because it's really easy to find the right angle, right? Because it's the box, and then just it's always across from it. And if you eliminate that and get that out of the way, and you always know which one that is, then you've got a 50-50 chance of trying to remember the opposite and the adjacent. And I think the way I always remember the difference between the two is always remember that adjacent means next. And if you see the word adjacent, it looks a lot like adjoining, right? And if you ever hear the phrase adjoining room, most of us know by this time that means the room next to us, the room that's kind of connected to us, right? And so if you can kind of keep that in your head, you should not have too much trouble keeping these separate from each other. Okay, so we got x, right? And we have the measures they're giving us is they're giving us adjacent and hypotenuse. So we are going to, we have our SOHCAHTOA, so we have our sine, which is equal to your opposite over your height, right? Your hypotenuse. You have a cosine, which is equal to your adjacent over your hypotenuse, and then your tangent, which is your opposite over your adjacent, or think of it as sine over cosine, right? This one over this one. Your hypotenuses would cancel out, and you have opposite over adjacent. All right, so that's how having that is helpful. So enough front loading here. Let's do this. So let's just set it up like we normally would. All right, so we're going to say we have the adjacent, we have the hypotenuse. You're going to use cosine. So we're going to go to cosine of theta is equal to my adjacent over my hypotenuse. Now let's put in what we know. So what we don't know is we don't know the angle. So but we're calling it x. So we're going to say the cosine of x is equal to my adjacent is 15 and my hypotenuse is 17. And so think we've got this over here and we've got this over here. So what we are going to do now is we're going to switch these around. Okay, we're going to take these and we're going to just flop these. Okay, just boom, just switch them around and you're good to go. All right, so if we take this, we go cosine, and when we switch them, you change this to your inverse. So you have the cosine, the inverse cosine of 15 over 17 is equal to x, which is my angle, right? And so at this point, you really can't do anything else other than just grab a calculator, all right? And so when you use a calculator, right, generally speaking, most calculators, you're going to have, your three buttons, right? So you're going to have your sine. They're usually like really close to each other. Most calculators are like next to each other. So you got your tangent, your cosine, and your sine. And then on most calculators that I've seen, if you look above them, they'll have writing on it above the button that says sine -1. And then this will say cosine -1. And this one will say tangent of -1, meaning these are our inverse functions. And then the button you're going to use to access those is called the second button, right? And so you find that button. This is for most Texas Instrument calculators. Okay, if you have something different than that, like, Casio or something else, which I'm sure it's probably pretty similar. So all you're going to do to access this function is hit your second button and then your function, right? The second tells you you can take any of it's almost like the shift key on a calculator, right? You hit the second button and then you can access any of the ones that are printed above for the whole calculator. And so you go find the one you want, and we want cosine. So that's how I'm going to do this. So I'm going to go second, and then I'm going to hit the cosine button, and that gives me it'll say, when I do that on the calculator, it says cosine -1, and it gives me this, and then it gives me the opening. And then you just put in 15 divided by 17. And then I write it like this. I just go 15 divided by 17 because remember, fractions are division problems. And then you just hit your enter or your equal button, whatever you have. And so then the answer I get is 28.1 degrees. All right, now you need to make sure when you're doing this that your calculator is set to degrees, all right, and not radians, okay? Degrees, not radians, right? We may at some point talk about radians, but we are focusing on degrees and using that because that's kind of how we know things in this. So we have now successfully solved for this. We kind of talked through it. We have these problems all set up to go. So I'm going to stop the video here, and in the next video, we're going to solve these next two. All right.